Hello everyone, so today we'll be discussing how to deploy a custom Pytorch model to AWS Sagemaker. So in order to do this, we will start by checking a pre-trained Pytorch model. This could be any model really. I will take a simple MNIST classification model. A simple MNIST classification model, but this could be anything really from generative models to classification, regression, whatever you want. Then we will build a FastAPI wrapper for this model. So the API that will call this model, we will Dockerize this API, then push it to AWS ECR, Elastic Container Registry, and finally we will, using Terraform, we will deploy an endpoint, an AWS Sagemaker endpoint. So in order to do this, there is some prerequisites. So for the prerequisites, you would need to install the AWS client and configure it. Then you would need to install Terraform, Python, and Docker. And that should be it. So these are prerequisites. I'll not be going through them during this video, but you could find resources online that will walk you through how to install this on your machine. So let's get started. So like I said, I will be using a custom Pytorch model. In my case, I will be using a classification model that is MNIST, trained MNIST model. So you can find some resources on how to train this model online if you want to do the same tests. Otherwise, just, I will be publishing this repo in the description below. So just go and look at this repo and try to reproduce the same thing. So, like I said, we will start by training a custom Pytorch model. So in my case, I took a custom MNIST classification model. You can take anything really, from image classification to generative AI, whatever you want. I'll be using this as an example, but in this case, nothing is really limiting you from modifying this processor to any kind of model. So first of all, let's start by creating a Python environment. I will call it vinv. Activate it. And let's install the requirements. Torch, we'll be needing PyTorch, Torch Vision, and FastAPI, and some other things, but we will be installing them later. So let's run the training. So as you see, I already done this. I run the training and I saved this model in this file here, model.pt. So the next step is that we will use this model.pt file to basically build our FastAPI application. So let's do that. Let's create a new file. Let's call it app.py, and let's start building our API. So first of all, let's start by importing what we would need. So we would need FastAPI, and from that we will import FastAPI and status. We will also import Pydantic, which is basically just to code the data model that the API will receive. And we will start by making some functions. So the first function would be to load the model. So I'll just keep them empty for now. We will have a function that will basically do the predict using the model. So we keep that empty as well. We do a function that do the pre-processing. We will have a function that basically loads and loads the payload basically. So the payload that is received by the FastAPI, the FastAPI API. So next up, we will need to start the app. So let's say FastAPI app here. And the first thing basically we need to do is to specify the data model for our input. So here let's call our input payload and say it's a Pydantic base model. And we know that what we will basically be sending are images. So we will call this image input, and it would be a list of floats basically. That's our list of floats. So yeah, this here needs to be a L with a capital L, and we need to import it from typing. Okay, so here we have our data model. So we will be sending our payload as an input as a list of float values. Now that I think about it, it will be a list of float values, because it would be a 2x2 image. And so what this does is just it allows us to kind of enforce this constraint. So anything that is sent different from this, basically the API will send an error if we get, for example, a string or something like that. So next up, we will be coding basically what our API is allowed to do. So the syntax for FastAPI, if you're not familiar with it, is you either will do a get or post calls, and it's written in this way as a decorator. So one thing here is that because we will be deploying this API on Sagemaker, we have to respect some requirements by Sagemaker. So for example, for a health check, you would need to get to send a get request at this route called ping, and what you would need to return is basically a string that contains pong, and in that case the health check status is passed. And in order to invoke the Sagemaker endpoint, you need to send this the data for the model at a route called invocations. So this is actually very important. If you don't do this, your deployment will not work. So let's call this function invoke, and for now let's keep it empty. Okay, so here we have everything that we need. We have our functions and for our API, and the only thing that is left to do is to populate this function with the logic that the API will basically do once we send it a piece of data to do the inference. So let's start by loading our model. So in order to load our model, we will need a model directory, and basically what we need to do, because we saved our model in Torch scripts, we would need to load our model in the same way. So here we would need to use torch.git.load. So we need to import torch. Let's do that, and we will join the path of our model directory to the name of our model. So here the name of our model is model.pt. Let's also import OS. And we will say here, because SageMaker, here I'm developing on my local machine that doesn't have a GPU, but SageMaker does have a GPU, so we could do a model dot true CUDA, so basically to say to the SageMaker to put the model on the GPU if torch.CUDA is available. Else, do nothing. And we will return the model. So here we did our function to load the model. Next up, let's do our predict function. So for our predict function, what we'll be needing to do is to basically give it as as arguments the input image. So let's call it image and the model. And what we'll basically be doing is that we will be calling the image on the model onto the image. So in order to do this, we need to go look at our model and see what we get as input. So here, if you notice, because I took the example of MNIST, I'm getting basically log softmax outputs. So in order to get probabilities, I would need to do a softmax on the dimension 1 in order to get a probability for each class. So here we'll be doing log, let's call this log props, is model applied to image. So here, one thing here is that the image would be the pre-processed input. So maybe I should change the name to pre-processed image here, so we can avoid confusion. And then what we will be doing is we will be sending back the scores and the class basically. So here we'll be doing probs equal torch dot softmax of log probs dimension equal to 1. And after that, we will need to get basically the highest probability and the predicted class. So proba and class is equal to torch.max of props dimension equal to 1. And after that, we will need to basically format our output. So one thing here is that the output needs to be a Python type that is basically the either list or string or things like that. We cannot be sending tensors. So here we will do .cpu. We'll detach if there is any gradients. We do CPU, and we do after that we will do .item basically .numpy.item, and the same thing for the program. Okay, then we will be returning the output. Great, we have our predict function. So next up, we'll be coding the pre-processing function. So the pre-processing function for the model needs to be the same as the pre-processing function that was used during the training. So here we will go in the training script. We will look here and we see that basically the pre-processing of the image is here. We change it to the tensor, then we normalize it. So we'll take this piece of code here and we will put it in our pre-processing. Usually would not be doing this like this. Copying code is not very well software engineering recommended. So you would basically import a pre-processing class from another file that is This class is used for both basically inference and training, do something like that. And that way you can have the same piece of code that is used in different places without copying it twice. So one thing we need to import from here is transforms from Torch Vision. So from Torch Vision import transforms, and the pre-processing function takes the image input as the build image basically here. So and we will be applying the transform to the image, and we will be returning the image itself. Okay, that's our pre-processing function. Next up, we will be looking at the payload. So in order to load the payload, we need to talk about what this function basically be getting. So here there is a mistake. This should be a post. And basically when we invoke the endpoint, we will do a post and we will send some data. This data would be in the form of our payload model. So it's an input, basically a key that is an input in a list of values, list of values, which is basically the 2D image for MNIST, because MNIST is a classification model that was trained on 2D images, so basically black and white images. In the case where you have colored images, you would basically have three lists here, and what you need to do is to basically take this, what we get is this payload, this base model as input, and you need to decode basically the input. So here we know that we will get an input as a payload. So let's move this here. So first thing, we need to transform it into JSON. So let's say input equals to input.json. So what this does is basically takes the input that is of this model and just gives it as a JSON value, and then we need to interpret this JSON value. So let's say input is equal to AST dot basically literal eval input, and let's import AST. And after that, we will be getting the image as input. Let's call it payload as to avoid confusion. Of input here. So what we did here is we got the payload as a dictionary, as a Python dictionary. This dictionary needs to be evaluated basically here, and it has key inputs, basically the string input as a key, and its values is the image itself. So basically that's what we did here, and we will be returning the image here. Okay, we have our functions ready, so let's make our invoke function. So the invoke function also takes the payload. The first thing we'll be doing is that we will load the payload, basically load the image from the payload. We will pre-process the image, then we will call our basically we'll call our model on the image, and we will return our output, that is a dictionary, and we can send it directly as is, because the dictionary will be converted to JSON, then it will be sent as a also as a payload using HTTP. One thing here, as you can see, we didn't load our model, so we need to do that. So this we will do before our we'll not be doing this inside our functions, because in that case the model will be loaded each time we do an invoke. We don't want to do that. We want to load the model with the app, so we will do it here. In our model directory, we know it would be just dot, because the model exists in the same folder as the app. So yeah, one mistake here, this should be output also. Okay, so here we have all our functions for the FastAPI, and the only thing left to do is to test it. Okay, so let's test our API. In order to test it, we need to run the app basically. So here app, we will run it in reload mode. We don't have UV-Cron, so we need to install it in our environment. Let's run it again, and our app is ready. Everything is initialized correctly, we don't have any errors, and everything is good. So the only thing we need to test here now is the logic. So let's do that up next. To test our app, we will be launching Postman. We'll be doing this, we're using Postman. You can use other tools if you are familiar with them. I like Postman because it's easy to use. So let's start with our health check. So here we know that we are running on our local host. So let's copy this. And we know that the path is ping bgh pong. Okay, so the health check is working. That's good. The second thing we need to do is to run a post request. So let us get a MNIST image as an input here. So we don't need the transforms here because we do it later. And let's get an item to see. So as you can see, the first element is an image. The second is the label 5. So let's do this again. And let's transform this to a list if we can. No, we can't. Okay, so this is our list. Let's copy it and let's head to our Postman and put it here. So this is basically our payload, and we will do a post method to the path invocations, and we will see what we get as a response. Okay, they say we have a server error, so let's go ahead to our app and see what we got. Yes, okay, so in our app, basically the transform here that we are doing, it should be applied to a pill image, but we're trying to apply it to a list. So this is normal, so we'll be changing this. So here we basically load the payload. So in the pre-processing of the image, either in the pre-processing or the load payload, we can basically change it to a pill image. So let's do that. So we need to import pill, so we need to install it also. So let's do that. And then import it. Okay, we already have it, so let's import it. From pill, let's import image. Then before either we do let's do it in the pre-processing. So here we have list image. So first thing we will do is image equal to image from array repeated array of image, and we need to import numpy. Okay, so here there was a couple of things. So we needed to add this to basically to tell the model to go to the CPU. The second thing we need to do is to add the pre-processing to the pre-processed image, the dimension of the batch. And finally, when calling the model, we use the predict function and not the model function. So yeah, if we test the model again, we get directly the class and the probability. Okay, so that's it for our model. What we have done is we built the FastAPI, we pre-trained the model. The next step is to build the Docker file and Dockerize the image, push the image to AWS, ECR, Elastic Container Registry, then using this image, deploy a SageMaker endpoint. Next up, we will be creating our Docker file. So let's create our Docker file. So one thing here, this Docker file will be running the app on SageMaker. So first things first, so basically we need the base image for the Docker file. Because we'll be working with a GPU image from on SageMaker, we need to basically start a Docker image based on the NVIDIA CUDA image. We'll choose version 11.4.3. You can go ahead and look at which CUDA version you would like to run based on which CUDA that exists on your machine. I find that this one works just fine, so I'm still using this one, but you can change it to a newer CUDA version. Maybe some benefits with that also. So we will install it using Ubuntu version 20.04. We will set some environment variables for Ubuntu. Then we will run the apt install, apt update and apt install dependencies. So one thing here, I will leave a link below in the description for this repository so that you don't have to write this all from scratch. You can just copy the Docker file and use it for your application. Next up, we will copy the requirements file. So let's say copy requirements. Okay, then we will run pip install requirements. We will set the working directory to dot. So this basically tells the Docker container to look for everything in the current working directory, and inside this directory we will make we will copy basically all our files except for main. We don't need main, so I will add a Docker ignore here. Say main.py. To this Docker ignore, we will add also the virtual environment and the PyCache so that we don't copy those useless files. Next up, so we copied everything in the directory except the main. Well, what we need to do is to set up basically our entry point. So One thing about SageMaker is that it's, instead of using Docker run, it uses Docker run serve. So that's a specific command that needs this specific configuration for the entry point. And if you try to run, to do a Docker run, a classic Docker run with this entry point, it will not work. But if you do a Docker run serve, it should work. So in this case, you can test it with that command. So the build failed here because I forgot this flag. So let's run it again. So here the build has succeeded. A few errors that you might run into because of the pip freeze. The requirements .text wasn't well formatted. So if that happens to you also, just copy the requirements .text that is in the repo and it should go through. Okay, so we have built our Docker image. Now it's the time to push it to our AWS Elastic Container Registry. So in order to do this, we need to move to our console and we type ECR here. We go to Elastic Container Registry. And as you can see, I already have my MNIST app repository created. For you, you wouldn't have that, so you need to create your repository. You choose private, you type MNIST app in the name and just click create, and you will have something like this. Again, I already pushed my image to this, so in order to do this for you, you would need to click on view push commands and just do these push commands one after the other. So let's do that together. So the first one is to log in to your AWS account. So if this doesn't succeed, that means your AWS account or your AWS client is not correctly configured in your terminal. So you need to set up this correctly. In order to do that, you can find many tutorials online that do that, and it's quite easy to set up actually. So the next command is to build the image. So we already did that. So we just tag it and push it. So for me, because I already pushed the image, it's quite fast. For you, it takes a couple of minutes to do this. It's normal, just wait for it to push. And if you go, again, if you come to this and just refresh, you should look at the latest image and when it was pushed. So now that our image is pushed, we need to basically build the endpoint. One way to do this is to do it through the AWS user interface. So if you go to SageMaker and you click on Amazon SageMaker and on inference, then endpoints, you can see that you have an option to create these endpoints by hand. The only thing that is noteworthy here is that you wouldn't want to do this by hand because, well, for once you would need to do this for each endpoint that would create, meaning for each model. And if you have a lot of models, it would be time consuming. You would want to do this programmatically. So in order to do this, we will be using Terraform. Terraform is basically a framework for infrastructure as code. So you type infrastructure as code and Terraform executes on AWS using API to basically spin up all the infrastructure that you declare as code. And I'll not be going through all the Terraform syntax, but you can find it on the Terraform documentation. The only thing that we'll be going through is how to basically spin up a AWS SageMaker endpoint using Terraform. Okay, so let's head on to our repository. Let's create a new folder. Let's call it Terraform. And let's create a Terraform file main.tf in which we will basically declare all our infrastructure. So the first thing we need to do is to declare a SageMaker AWS SageMaker endpoint. So let's do that. So as you can see, we can just copy this here. I'm just gonna leave a little bit of space. So let's call it MNIST endpoint. Let's change the name here as well. And the configuration name here, we will worry about that later. So let's do mnist endpoint as well here. So here it says that you need an endpoint configuration. So that's something we also need to go look at on Terraform. Sagemaker endpoint configuration. So let's copy this. So let's call it mnist configuration. This is not really important. You can call it whatever you want. Let's call it mnist variant. Then it's asks us for a model name. That means we need to specify a model name. So Terraform, in order to basically specify the model name, it says you need to declare the AWS SageMaker model. You can call it M, then give its name. So same as this right here, this is happening also in the endpoint. So here we need to declare AWS SageMaker endpoint configuration, which we has done, and we need to specify its basically its name here. So this is it, and we say that name to get the variable name. So let's say here mnist config. You specify the instance type. So here you can specify whatever you want. It depends on the resources for your model that you would need. What I usually like to specify for every one of my models is basically a machine with a GPU. So this machine would be called, if I'm not mistaken, G4DN X large. So let's change that here. And you specify the initial instance count, how many of these machines you want to spin up, basically. Okay, so one thing is missing here. So the model name refers to an AWS SageMaker model. So we need a resource that is called SageMaker model. So let's go look at that. AWS SageMaker model. And this is where we specify our model and everything that is associated with it. So let's call it mnist model. As you can see here again, in order to create this AWS SageMaker model, you need an execution role, which is basically a role that gives Terraform the authorization to install or to spin up a model in SageMaker, to basically have access to SageMaker. So we will do that next. And the second piece of data you need is basically the container image. So in order to, so we will keep this, we will first of all parameterize this as a variable. So let's call this var.containerimage. And we put it here, variable container image. And the last resource that we need to create is the AWS role that has access to SageMaker. So first of all, you want to create a SageMaker policy, assume policy for SageMaker. So this is it. So the second thing you need to do is to associate this policy with a role. Let's call this, let's declare this resource AWS IAM role. Let's call it SageMaker access IAM role. Let's change this name to SageMaker IAM role. And basically what we're saying is that this role would assume the policy that is declared in this data structure right here. And the last thing you need to do is to tell the role that it needs to attach to another policy, that is the Amazon SageMaker full access policy. So here we say it's an AWS IAM role policy attachment, and we say that we attach this role to the Amazon SageMaker full access policy. Okay, that should be it. So here we just need to change this to the name of our role. So the name of our role is SageMaker Access IAM role. So let's change this here. And the only variable that we need to give to this Terraform model is the container image. Let's specify an output. This output will be the endpoint name and IRN. So our endpoint, we call it mnist endpoint, so we need to change this here. And that should be it. We have our infrastructure ready for deployment. So the only thing we need here is a file called .tf-vars. So let's create it, terraform.tf-vars. And in this file, we will specify basically the container image. Okay, so let's change to this directory. Let's list. We have main.tf and we have our terraform tf-vars. So let's do terraform init. Okay, let's do Terraform plan to validate our file to see if anything is missing. Yes, it seems that we have an error. We say that we are declaring a model M, except it's not called M, it's called mnist model. So let's change this here. Let's do Terraform plan again. Okay, it says that the instance type is not correct. It seems that we need to add the ml dot here. Let's do it again. Okay, and now it passes. So let's do Terraform apply, auto approve. So a quick note here, if you're running a Docker on a Apple M1 chip or M2 chip, the new Apple chips that are that have been released with the new Macs, you need to specify the platform to be Linux AMD 64. Otherwise, your image will not work on a Ubuntu machine. So if you have an Apple machine, run Docker build with the same command, just add the platform flag and then push the new image to your ECR before deploying with Terraform. So the output of Terraform apply should be something like this. You should see the resources that were created, and if you go look at the endpoints on Amazon SageMaker, you should see that there is an endpoint that is in service, and you could look at the logs and you can see that the app was created and is up and running. The last thing here that we can do to test the endpoint is to call it using Boto3, and I prepared a little script and we will see how to do that up next. So in this script, we will create a dictionary that holds the input. We'll declare the endpoint name, and we'll just call Boto3 client with SageMaker runtime with the correct region name. We will invoke the endpoint using its name, and by dumping the data into a JSON, basically a JSON dictionary. And if we run this script, we should see exactly the same output that we got using Postman. So that's it for this tutorial. I hope you found it helpful. If you did, please like and subscribe and hit the notification button. We'll be uploading other videos on how to deploy other models in Amazon SageMaker, how to incorporate CI/CD, things like that into production.